Boys, today we will start a new topic for class 12, and that is also very important topic. The name of the topic is probability. Probability. We have discussed basic concepts of probability in class 11, and just I want to revise that concept, that this probability is defined as the number of outcomes favorable to an event divided by total possible outcomes which are mutually exclusive, exhaustive, and equally likely. So the probability of an event we can define as number of outcomes which are favorable to an event divided by total possible outcomes which are mutually exclusive, exhaustive, and equally likely when a random experiment is performed. In case of a random experiment, let us take a recap of class 11 probability. We know that an experiment is an act. This experiment is defined as an act which has outcomes. Any act, if you are doing experiments in your physics lab, if you are taking the volume reading, or if you are taking the length reading, so any act which has outcomes, that act is called an experiment. And after experiment, here we have to define random experiment. So random experiment is that experiment which has outcomes, but outcomes depends on chance. The outcomes, if the outcomes depends on chance, outcomes it attached to experiment, and for any experiment means which has outcomes, if those outcomes depends on chance, then in that case we call such type of outcomes as such type of experiment as a random experiment. Now, a random experiment, the examples, you can take several examples, that tossing of a coin, throwing of a die. So if a die is thrown, then in that case we don't know which outcome will appear, but we have 1, 2, 3, 4, 5, 6, the 6 outcomes. Out of these 6 outcomes, any one can appear. So this depends on the chance that which outcome will appear. So such type of experiment is called a random experiment. And the outcomes of a random experiment are called events. Means if a coin is flipped, then in that case we have 2 outcomes. One is head, another one is tail. So head is an event and tail is an event. Occurrence of head is called an event. Occurrence of tail is called another event. So any random experiment has outcomes, and these outcomes are called here in probability as an event. Now, these events should be equally likely. What it means? Actually, equally likely means without giving priority to anyone. Suppose in your section there are 70 students, 60 students, 50 students. Suppose there are 50 students in your section. Now, if you want to select any one student, you just write the names of those students, all the students, on similar slips, and keep all these slips in a drum. Mix them well, and now pick up any one slip. So this means that you are giving priority to all, that the name of any student may appear in this trial. So such type of experiments are equally likely. But the one thing you must keep in mind, that this equally likely does not mean equal probability. This does not mean equal probability, because here outcomes are occurring without giving priority to anyone. So equally likely does not mean equal probability. For example, if a perfect dice is thrown, then in that case occurrence of 1 and occurrence of an even number, the two outcomes, if we want to check what is the probability of occurrence of 1, what is the probability of occurrence of an even number, then the two outcomes are equally likely. Means when we flip the dice, then when we throw the dice, then in that case we may have 1 as outcome, we may have an even number as outcome. So the two are equally likely, but they have different probabilities. Because if you calculate the probability in the first case as you have done in class 11, here in this case probability will be 1 by 6, and here the probability will be 3 by 6, that is half. So the two probabilities are unequal, though the events are equally likely, because we don't know whether an even number will appear or 1 will appear. So outcome should be equally likely. And then here we have outcome should be mutually exclusive. What this word stands for? Mutually exclusive. This means mutually exclusive. This word indicates that the outcomes, two or more outcomes, are said to be mutually exclusive if they do not occur simultaneously. If two or more outcomes, if they do not occur simultaneously, then in that case we call them mutually exclusive. For example, suppose a coin is flipped. Now if a coin is flipped, then in that case when head will appear, it stops the occurrence of tail. Or if tail will appear, then it stops the occurrence of head. Both will not appear at the same time. Head and tail both. This will never happen. Means coin should not be in standing position. So here mutually exclusive means occurrence of one stops the occurrence of the others. Or in the second way, we can say that events should not occur simultaneously. And in Venn diagram, we can represent mutually exclusive events using the two circles, this one and this one. Here it is A, here it is B. So A is one event, B is one event, there is no common portion. And we call that for mutually exclusive events, A intersection B, that is number of outcomes favorable to A intersection B is 0, and therefore the probability for mutually exclusive events PA intersection B, it becomes 0. This thing we have discussed in class 11. PA intersection B is equal to 0. So mutually exclusive. And exhaustive events, it indicates, there is a word, exhaustive events. Now a set of events are said to be exhaustive if at least one of them must occur. At least one of them must occur indicates that we have a set of so many events. Out of these events, if we perform the experiment, the random experiment, if we perform, then the outcome, the event will be any one of these given events. Now, what it means? Suppose we have outcomes given 1, 2, 3, 4, 5, 6. Now, these 6 outcomes are exhaustive if a perfect dice is thrown. But if we omit this 6, then from 1 to 5, this is not a set of exhaustive events when a perfect dice is thrown, because if we throw a dice, it may happen that 6 will appear, and that 6 is not included in the picture. So yes, this set of events should be exhaustive if we include 6 also here. So out of these 6 events, any one will appear if you throw a perfect dice. So this is the meaning of exhaustive events. Here we can also say the exhaustive events, it implies the sample space. Sample space, sample space which we have discussed in class 11, if we denote this sample space by S. Now a sample space is set of all possible outcomes of a random experiment. If a random experiment is performed, then we have to prepare a set of all possible outcomes, and that set of all possible outcomes will form our sample space, that is denoted by S. So in case of throwing a perfect dice, we can denote S by this. S is equal to 1, 2, 3, 4, 5, 6. So if a perfect dice is thrown, the sample space is given by this set. Now, suppose A is an event, A is defined as event of occurrence of a multiple of 3. Say, then what is probability of A? If we want to know it, what is probability of A? Then in that case, we will search that how many numbers are favorable to this event. Favorable to this event means NA, number of outcomes which are favorable to event A, and then NS means total possible outcomes of the random experiment. So this NS means number of outcomes in the sample space. NA by NS, this is the definition of probability which we have discussed so far. Now NA, if you observe it, multiple of 3 are here 2 numbers. So number of outcomes favorable to A is 2 and the total possible outcomes is 6. So we divide it and we will have 1 by 3 as our answer. So in this way we have calculated probability in class 11. Now here we have to start a new concept of probability, and that is called independent events. Independent events and conditional probability. So from here our syllabus of class 12 begins. Independent events and conditional probability. Before discussing this conditional probability and independent events, I will explain you few formulae which we have used already in class 11. That is the number 1, P A union B is equal to PA plus PB minus PA intersection B. This thing we have discussed earlier. And then number 2, PA is equal to PA intersection B plus PA intersection B bar. And then number 3, PB is equal to PA intersection B plus P A bar intersection B. These two are called the axioms of probability. This one is formula for union of two events, plus of two events. Here in set theory, this union, and here in probability theory, this union is denoted by plus. Remember it. And the intersection, which was here, they are in set theory, that is indicated here by dot. Means if we are writing PA intersection B, instead of this we can write PAB. PAB, you can write PAB. The same meaning. If dot exists, then this means intersection. So you must keep in mind that here in probability, this new concept of union, that is plus, or intersection, that is dot, introduced. Now here, the two are the axioms. You can verify all these using Venn diagram. So if you prepare a Venn diagram, there you will find that A and B are two events. Now A event is made up of A intersection B, this one, A intersection B, and then A intersection B bar. B bar means except B, whatever remains, the intersection, the common portion of A. So this one is called A intersection B bar. This part is A intersection B bar. This part is called A bar intersection B. This thing we have discussed in class 11 in detail. So A intersection B bar, this dotted portion, A bar intersection B, this blank portion, and A intersection B, this stripe. So if you add this stripe, that is A intersection B, now if you add A intersection B with A intersection B bar, you will get the full circle of A. So that's why this formula. And here this blank portion with stripe, if you add, you will get PB, this formula. And PA union B, you know the PA, it includes the common portion. PB, again it includes the common portion. So one time we have to subtract that common portion, that is minus PA intersection B. So this thing we have discussed earlier. Now here we have to start conditional probability. So let us define what is the meaning of conditional probability. Conditional probability. Probability. The probability or conditional probability, the probability of simultaneous occurrence of events A and B is given by the product of unconditional probability of event A with the conditional probability of event B, assuming that event A has actually occurred. Symbolically, we can write P A intersection B is equal to PA into P B slash A. This is the definition of conditional probability. We will explain it one by one. Now, first of all, we have to explain the symbol P B slash A. What it means. You see here, whenever there are two events and the occurrence of one event depends on the occurrence of other, the two events are called dependent event or conditional events. Say, I will give you rupees 10 if head will occur if you throw a perfect coin. So there are two events. One, the occurrence of head, and the another event is giving rupees 10. Now if head will appear, I will give you rupees 10. So there are two events. And what will happen if tail will appear? Nothing is given. So you will not receive rupees 10. Now, if two events are conditioned by one another, means if we want to find that what is the probability of gain of rupees 10, then in that case we should have head on the coin. Now, one event already occurred, and then the second event will occur, and to denote it, say P A slash B. So P A slash B means probability of A. Remember it. probability of A under the condition that event B has actually occurred. Remember, PA/B indicates probability of A. But when probability of A, it is probability of A, but after the occurrence of event B. Say, if you have a well shuffled pack of cards, suppose, there are 52 cards in a pack, 52 cards, having 13 for each denominations, 13. Thus 13 club, then 13 heart, then 13 spade, then 13 diamond. So these are 52 cards in a pack, well shuffled pack. Now after well shuffling the pack, suppose if we keep a card aside, if we keep one card aside, now we have 51 cards in the pack. Now again, if we want to know what is the chance that a king will appear from that 51 cards, now to know it, we have to consider two cases. The first one, whether we have kept the card aside, if that card is a king, then in that case we have 3 kings with 51 cards and the probability will be 3 by 51. But if that card is not a king, then in that case we have the probability as 4 by 51. So what you observe here, that probability that second draw will be a king, it depends on the first draw. Whether first draw is a king or is not a king. In both the cases we have different probabilities. So here is the case of conditional probability. That probability of second is a king. This one is second draw, second king, such that the first is a king or first is not a king. If first is a king, B is the event that occurs first. Now this event, the first card drawing, if it is a king, here PA/B becomes what? 3 by 51. But if B is not a king, then it becomes 4 by 51. So this is your concept of conditional probability. Boys, in the next video, we will extend this topic. So for today, this is all over. Thank you.